Okay, let's take a look at another functional equation. So this one is find all function f, which is from real number to real number that satisfy f of x minus 1 quantity square equals to f of x quantity square minus 2x times f of y plus y squared. So this one is very interesting. So we observe that on the right hand side, we may try to complete the square, but it is not good enough. So if we want to have a f of x quantity square and then y square, if we want to complete this square, it should look like f of 2 times f of x plus y. Then we can complete this square as f of x minus y quantity square. However, x and y is swap for the middle term. So next, we would like to observe that on the left hand side, x and y is symmetric. Which means that if we exchange x and y, then on the left hand side it will be the same. So we can just write it out like this: f square equals f square minus 2 times f minus 2 times f, and then plus square. So we can first write it like this. So we have a x here, still have a minus sign. So on the here we have x here. So we have x and x here. And on the second one, we can write it as y, and y. So next, we observe that here is y, and y. So that we have y, and y. And then we have x, and x. So in this case, we swap x and y on the left hand side, which means that they should be equal to each other. And in this case, on the right hand side, they should also be equal to each other. So let us rewrite it like f of x quantity square minus 2 times x times f of y plus y square, and then equals f of y quantity square minus 2 times y times f of x plus x squared. So now we can try to move this term to the right side and move this term to the left hand side. So in this case, we have a f of x quantity square minus 2 times f of x times y, which is this term, plus y squared. So equals to f of y quantity square and then minus this term, which is 2 times f of y times x plus x squared. So we successfully swapped the x and y for the middle term. And in that case, we can complete the square on both sides. So on the left hand side, we have f of x minus y quantity square equals f of y minus x quantity square. So we can take the square root on both sides, but remember to add positive, negative sign, plus or minus sign on either side. So for the case 1, we have f of x minus y equals f of y minus x. And for case 2, we have f of x minus y equals, with a negative sign, so we swap the order. We have x minus f of y on the right hand side. So we denote it by equation 1 and this one by equation 2. So for equation 1, we can move the term with x to the left hand side. So we have f of x plus x equals to f of y plus y. So we just move this term to the left hand side and move this term to the right hand side. So in this case, the left hand side is a function of x and the right hand side is a function of y, which means that they should be equal to a constant. Which means that here we have f of x should be minus x plus c. And for the second one, similarly, we can just move f of x, move x to the left hand side and y to the right hand side. So we have f of x minus x equals minus f of y plus y. So for the left hand side is a function of x, and on the right hand side is a function of y. So they should be independent of x and y and equals to a constant. So in this case, we have f of x should be x plus c. So actually we have two sets of solutions, which means that f of x should be plus or minus x plus a constant c. So let's double check it, which means that we substitute this into the original equation, which is f of x minus y squared, and then equals f of x quantity squared minus 2 times x f of y plus y squared. So on the left hand side, f of x minus y squared, which is plus or minus x minus y squared plus c. So for the right hand side, f of x quantity square minus 2x plus f of y plus y squared should be, f of x should be plus or minus x plus c square minus 2x times plus or minus y plus c plus y squared. So this would be x squared plus or minus 2xc plus c squared minus plus 2xy, and then minus 2xc. Let me see. Yeah. So we have a plus y squared. So in this case, for the upper side, we have a x, this term, and this term. We have x minus y squared, and then plus 2xc and minus 2xc can be cancelled, and then plus c squared. And then for the bottom case, we have x plus y square, and then plus, negative minus 4xc plus c squared. So for the bottom case, this should be reject. This should be reject. And for this one, we should know that c should be equals to c squared, which means that c should be 0 or 1, which means that only positive x is okay, which means that f of x should be x or x plus 1. We only have two solutions. Originally, we have two sets of solutions, but it turns out to be two solutions for this functional equation. And this is the end of this video.